This is the second of the 3 video segments that I'm going to be making for design table, and I suggest you look at it, watch the first one, because there I explain to you why is it that the way I'm doing it, the way I'm doing these 3 video segments is different from what was done a few years back. Okay, in the old days I used to create parameters and make equations and things like that to take care of my design table. But since last year I decided to do it a different way. I'm going to be using renaming parameter and proceed. Okay, so the problem that I'm going to be doing is right here. The design table is given up there, so this is what you're going to be creating. And notice that there is a comment made here that these kind of comments appear very frequently on my test, so you have to pay attention to it. It says that the edge, this edge, and that edge, they must pass through the center of that circle, and of course for this one, this edge must pass through the center of that circle. Okay, so very important. All right, let's go ahead and make it. Let's get down to Catia. There's the Catia. I created the part file, and right away I'm going to save it. Save management, save as, desktop, new folder, problem 2, and say OK. And remember, on the day of the test, this is the kind of thing you have to do. Problem 1, problem 2, problem 3. Put all your stuff in the right folder. And in the case of design table, you also have to put the Excel spreadsheet that you're creating in that folder. All right, let's go ahead and make it. On the vertical plane, I'm going to make something that resembles this thing that you saw there. Okay, I suggest you take a screenshot of that if you want to, or write it down so that I don't have to go back and forth between it. So let's see, there are different ways of doing this. So let me proceed maybe like that. I'm going to make my my circle here. I'm going to do half of this thing and reflect it on the other side. That's one way of doing the problem. Okay, so then another circle up there. All right, and then the lines. So there's a line that goes from here to here. Okay, and then yeah, let's do. Let's see now. Another line that goes from here to here. Feel free to do this problem any way that you want, but actually I just noticed that this line, I don't want it to go there. I want it to stop there. Okay, and then like so. Okay, good. Now, okay, so let's do the following. Mirror these things on the other side. Let's see now, where's the mirror? Mirror is right there. So we mirror this with respect to that. We mirror this with respect to same thing. You don't have to do it one by one. You can select them all at once and do that. Do the mirror. For example, this control that. Oops. Uh-oh. Control Z. Never mind. So mirror this with respect to that, and mirror this guy with respect to that fellow. Okay. Why don't I also do the mirror of this thing? That circle with respect to this. Okay. The advantage of making a mirror is that symmetry is maintained. Otherwise, you have to make sure that the points that you create have to be symmetric with respect to the middle line, etc. Let's do a cleanup here. For example, quick trim. I may have to redo some of these things. We'll see. Quick trim this. That piece is going to go. And that piece. Okay, and that piece. Let's see now, that guy, what have we got? These and that. See, maybe I should have done this thing first and then mirror it, because now I have to do the exact same thing on this side. But that's okay. There. Okay, now notice that if everything is done correctly, first of all, let me save this. If everything is done correctly, you can move these things. Whoops. Oh, yeah. Look what happens. That's because this line is not guaranteed to go through that point. Okay, so this is a constraint that you have to put. So that point, control this point, they must be coincident. This point, this line, control that point, they must be coincident. Same thing on this side. This line, control this point, they must be coincident. See, by mirroring, doesn't mean it's guaranteed on the other side, so we have to do all of them coincident. And I bet this is going to cause a problem because there's no guarantee that this, well, actually, no, it looks like this one we don't have to do. Because we mirrored this thing and this goes through that, and the circle is mirrored on this side, everything's okay. All right, let's go and put the dimensions like that, okay? So let's see now, what are the parameters here? This radius is one of the, right? This radius is one of the things that we want to use in our design table. What else do we have here? This radius is called R1 in the design table. And I'm talking about these guys, okay? What else do we have? This length is L, later in the design table. This dimension here is going to be A, and the dimension here is going to be B. What else do we have? The angle. The angle between this line and that line is going to be later on beta, and the angle between this line and that line later on is going to be alpha. Good. So exit, we pad it. All right, let us apply dummy material to it right now. So metal, aluminum on the part. Very good. Now we're going to rename our parameter. So you click on f of x. As soon as you click on the part from the tree or from the screen, all the dimensions that you put in there are going to appear. Now, I suppose I can, because this is already filtered as strings, okay, so I can change the material to my math. My math. We did this thing in the first video clip. My math, my material, and the name, part number or part name. I'm going to call it my part name. How about serial number? Serial number. Well, actually, let's call it serial number so it's exactly the way it appears in the Excel spreadsheet. Okay? Apply. Now, let's do the dimension that or length. So I said, show me all the length parameters, everything. In fact, because I can filter this thing as both length and later on angle, but let's make it all. That's fine. All right. So let's see now. This guy is going to be R2. R2. Apply. This guy is going to be R1. Apply. This is going to be L. If you look at the screenshot that you took, you see that was called L. This is B, little b, I suppose, little b, apply. And this fellow is little a, apply. This angle is beta, apply. And this angle is alpha, A-L, all you that. Okay, alpha, apply. And we say okay, because I've already done the material and I did all these dimensions. Very good. Now we go to the design table right there in the knowledge toolbar, design table. Now we are creating it with current parameters, so it's the second radio button that you want and the default vertical arrangement. Now it says, all right, what do you want to put in your Excel spreadsheet? First, let's look at the other renamed one. Well, these are all the renamed one. Okay, these are all the things that I want to do. And the order, depending on how you pick it and send it to the other side, that order is going to be maintained in the Excel spreadsheet. Now, even if you have a different order, you can always rearrange these things later on if you need it. There's another way of doing it. So in the first column, I want, I suppose, serial number. Then I want material. Then if you look at the Excel spreadsheet, this is the one that I'm talking about. Next one is R1. Next one is R2. Then it's A. And then it's B. And then L. And then alpha. And then beta. And we say OK. It says, where do you want to put it? Obviously, I want to put it in problem, the folder, which is called problem 2, and give it the name that you want. I'll keep the default name table 1 here. And just wait for a second. There we are. So now we want to, these are my nominal dimensions and properties. So I'm going to go say edit table and just complete that table the way it was presented to me on the paper. All right, so according to this, if you look at this screenshot, so it's going to be C001 and then steel. Remember, the spelling has to be exactly the way it is in your database. So uppercase S and then teal, okay? And then 1 and 1.5 and A is 1, B is 1, L is 3. I'm sorry, this B is 3 according to the table. The next one, L is 3, alpha is 70 degrees, and beta is 110. Then it's C002. Okay, material is copper, big C-O-P-P-E-R. 0.5 for R1, 1.5 for R2, 0.5 for A, yeah, 2 for B, 4 for L. The angles are 45 and 90. And finally C003, iron, big I-R-O-N. Okay, 1.5, 2, 4, 4, 30, and 150. 150. And save it. This is going to be the replicate of that table, except there's an additional row here because I did it in nominal one. You can delete that row if you want. If it's bothering you, you can delete it. So remember, after you save, you have to close it and wait for the update knowledge report dialog box to appear. You close it, there are no error messages. You can see that. So here, this is the nominal one. If you go to the second row, you select the second row and then say apply. Notice that part name changed, material changed, and it's the dimensions that you want. And then again, apply. Yep, new part name, new material, dimensions that I want, and apply. There we are. Okay, now what I'm going to do is, first of all, I'm going to say okay. I want to show you what happens if you ignore those constraints. Remember those constraints that I put the line go through the center of the circle? So let's go to one of these sketches. Where's the part right here? Let's go to the sketch and let me remove some of these. For example, remember these constraints? One of them was that line going through this. Okay, you can see that if I select this, you can see the bottom line. The bottom line goes through that. So let me take this and delete it. Okay, and same thing here. Let me select that. This constraint is for that line passing through this. I'm going to delete it. Let me try to move these points, see whether I can do that. So you see, things can get, obviously this is not right, okay? As a matter of fact, if I delete, for example, this point, now I can even move that. And this is going to become really ugly. So these notes that you may see, they have to be respected. Otherwise, the part that you're going to get is not going to be correct. In fact, let's go back to, remember I deleted these. That's fine. As a matter, yeah, I deleted these. So let's go back to exit this. Go to my design table. Okay, let's see how it looks like. For example, if you go to, I don't know, that guy. Okay, notice that these lines do not go through that. See that? Yeah, and of course it's not going to be right. So in fact, in some cases, if you do not put those constraints there, the sketch may collapse, and once it collapses, then you cannot go back into the previous rows unless you undo and go and fix it. So that takes care of my second problem. Let me save this thing.